This is part 9 of the Module 11 lecture. In this part, we're going to talk about this example, and it's the same that we've been talking about in previous parts, where a student has an off-campus job, and this person works 8 hours per week, and this person is thinking of increasing his workload of external work to 16 hours per week, and he wants to find out how much that will impact his GPA. Now, we're using the data from the Department of Institutional Research, where they provided information for a random sample of 10 students, where we have their GPAs and the corresponding hours they work per week. Now, we're going to assume for this example that both the GPA and hours worked per week are normally distributed. So we want to find out two things. We want to calculate the sample linear correlation coefficient for GPA and hours a student worked each week, and we would like to test the hypothesis that the linear correlation coefficient between GPA and hours worked per week for all students is not 0, and want to use a significance level of 0.05. Now, I underline the word all because I'm referring to the population linear correlation coefficient. And we would like to test that and find out if it is equal to 0 or not. All right. So let's first calculate the sample correlation coefficient. For that, we use information that we have already calculated for example, finding the estimate of the slope parameter and some squares of the y that we use to calculate the standard deviation of the residual. So these quantities have been calculated, and we're going to use them in this equation to calculate the correlation coefficient. So now, putting these numbers into the equation, we find that the correlation coefficient is minus 0.6781. All right, so we know two things. First, this is a negative correlation coefficient, and this correlation coefficient is close to 0.7. So we could say that there is a moderate negative linear correlation between GPA and the hours worked per week. All right, so this is what we could say about this number without any other knowledge. What we would like to do next is determine if the actual correlation coefficient, that is the population correlation coefficient, is 0 or not. Because if it is 0, then we know that even though we have apparently a moderate correlation, that this will mean that it's really not statistically significant. All right, so this is a two-tailed test, and we have a significance level of 0.05. So we saw earlier that since both GPA and hours worked per week are assumed to be normally distributed, then that's the sole justification that we need to use the t-distribution with n-2 degrees of freedom, in this case 8 degrees of freedom. All right, so now that we know the distribution to use, we will proceed to calculate the test statistic. And here I put here that this is the correlation coefficient that we just calculated, and we're going to use that to calculate the t observed, or the value of the test statistic, and the number of observations in the data set, which is 10. All right, so putting those numbers into the equation and carrying out the calculation, we find that the value of the test statistics is minus 2.6096. All right, in step 4, if you are asked to do or use the critical value approach, then you remember that this is a two-tailed test. So we have two rejection regions, the lower and upper rejection regions. And then we use table 5 with alpha divided by 2, because this is a two-tailed test, with the 8 degrees of freedom. So if we use the degrees of freedom, look at that row on table 5 for 8 degrees of freedom, and then look at the top and find the probability of 0.205. And if you come down and with that column and that row intersect, you find the upper critical value, which is 2.306. Then rely on the symmetry of the t-distribution, and then we know that the lower critical value is minus 2.306. All right, so the fact that you find the critical values doesn't mean that you know where the rejection regions are. So you have to specify that. So don't forget this. In the exam, if I ask this question, you need to specifically write out what the rejection regions are. So in this case, the lower rejection region is that for any t-value less than minus 2.306, or for any t-value larger than 2.306, it will imply that then the null hypothesis will be rejected. All right, don't forget to specifically write out the rejection regions for if you're asked to follow the critical value approach. If you are asked to follow the p-value approach, then what you would do is on table 5, on the row for 8 degrees of freedom, you will see where the t-observed is with respect to the numbers listed on that row. So the t-observed is 2.6096, and then you see that it's between the values of 2.306 and 2.896 on the row for 8 degrees of freedom. The 2.306 corresponds to a probability of 0.025, and 2.896 corresponds to a probability of 0.01. Now, because this is a two-tailed test, the p-value is 2 times these probabilities. So then we can say that the p-value is between 0.05 and 0.02. So if you like to find the exact p-value, you can use this formula in Excel, and you find that it is 0.03115. All right, so with this, we complete step 4. Then in step 5, then we make a decision about the null hypothesis. So since the t observed of minus 2.096 is smaller than the lower critical value, then t observed is in the rejection region. Also, we know that the p-value is smaller than 0.05. So following either approach, we know then that the null hypothesis should be rejected. So in other words, the population correlation coefficient is not 0. So how do we interpret this? Well, in this case, we need to use both the point estimate of the correlation coefficient that we calculated at the beginning of this problem, minus 0.6781, and take a look at the scatter plot. So in here, we already saw that we have a negative relationship that is moderate, and that because of the points on the scatter plot, we see that is linearly decreasing. So then we can conclude that there is a non-zero moderate negative linear correlation between GPA and the hours worked per week for all students at a significance level of 0.05. So again, please note that we put all three things together. So the point estimate of the population correlation coefficient, which is the one we calculated, what we see in the scatter plot, so that we see there is a linear trend and is decreasing, and that this is a non-zero correlation. All right, so keep this in mind when you interpret the results of the hypothesis test for the population correlation coefficient. All right, so we're done with this example, but what I'd like to show you is how you can get the correlation coefficient in Excel. Again, you need to have this data analysis tool pack installed. Again, if you haven't done that, you can see the instructions on Blackboard. Once you do that, open the worksheet so you can see the data. And then on Excel, go to the tab that says Data, click on it. And then once you click on it, then you see all these options, and go all the way to the right and click on the button that says Data Analysis. If you don't see it, it's because you have not installed the Data Analysis Tool Pack. You need to install it so that once you do that, then you will see this button. All right, so I'm assuming that you installed it successfully. So click on it, and then this window opens right here. Then click on Correlation, and then click OK. And let me switch over to Excel so that we can see how this is done. So give me a second. All right, so here's the data set. And then we click on Data right here. And then you see the data analysis here at the top. Click on that. And once you click on that, you see that this window opens, and then you look for correlation right here. So once you select correlation, I click on it, then click OK. Then this window opens and you see that it's looking for the input range for the entire data. So in this case, what you do is you simply, once the cursor is blinking on that window, just click on the very first cell of your data set and then drag it all the way so that you include both columns of data and all data. Once you do that, then you have input the range of the data. Then because we included the labels, click on labels in first row and then click OK. So we're going to get a new worksheet with the output. So once you click OK, you get this output. And let me just double click at the top so that I widen the row, each of the columns to see what the titles are. And here's the correlation coefficient right here. This one refers that hours worked per week is perfectly correlated with hours worked per week, as you would expect. And also this one over here is saying that GPA is perfectly correlated with GPA. I think that's obvious that that will be a perfect correlation of 1. But this is the correlation we're looking for right here. So Excel can calculate that for you. All right, so let me go back to the slides. And so in the next slide, I'm showing everything that I show you on Excel. And here's the output. So here's the correlation coefficient that we're looking for. And so if you rather get the correlation coefficient using Excel, then you know how to do it. All right, one last thing that I'd like to talk to you about is this idea of correlation and causation. So again, a correlation different from 0 does not imply that the X variable causes the Y variable or vice versa. In other words, to say that we have a valid cause and effect relationship is that two things. Number one, you must have a significant correlation between the two variables. And two, there must be a logical reason for one variable to affect the other, either because of your knowledge of the physics of the process or the chemistry or the biological process or what have you. There must be some logical reason that indicates that this variable affects this other variable. As an example, I got this idea a long time ago when I was doing a project with students at UIW, and I asked them to measure their head circumference, and then I asked them to give me their GPA. And for this particular sample, we found that the sample correlation was 0.78, and on a significant level of 0.01, we found that the population correlation coefficient is not 0. In other words, the size of the head and GPA is positively correlated. So this means that the bigger your head, the larger your GPA. I mean, that's what the data is saying, right? But the second question, going to what gives us a valid cause and effect, is would it make sense that the bigger your head, bigger than your GPA? And there is no reason for that. So this is not a true cause and effect relationship. Okay, so please keep in mind, because people abuse the idea of correlation so much that just because there is correlation, there must be something happening. This must be causing that. And that's not necessarily true. That needs to be studied in detail and prove that correlation. Now with COVID-19, there are so many ideas flowing around, but just because there is correlation, that doesn't mean that this causes COVID or that this cures COVID. No, you really need to understand the physiology of the virus and how that interacts with the body to really know what is a reliable cure. All right, so I'll stop here and we'll continue with the next topic later.